Distillation is a technique for the purification and separation of volatile compounds. In this demonstration, I shall show you how to carry out a distillation done at atmospheric pressure. But before doing any manipulation in the laboratory, it's essential that you remember always to wear safety glasses. We shall carry out this experiment entirely in the fume cupboard, and that's because we shall be using a Bunsen burner as a source of heat. I shall begin by showing you how to assemble the apparatus. You will need a round-bottomed flask, chosen in size so that it's approximately half filled by the liquid that you're going to distill. Clamp this gently but firmly above a tripod and gauze. Notice how the clamp is supported on the retort stand by a boss. The boss is oriented so that it is underneath the shaft of the clamp. Into the flask, we put the still head. Connected to the still head is a Liebig condenser. Clamp this approximately halfway along the shaft. And then at the end of the Liebig condenser, we shall put the receiver adapter. Notice that there's a lip at the end of the condenser here. Rotate the condenser so that the lip is pointing down, and that will aid in the collection of the distillate. So attach the receiver adapter, and then finally a flask to collect the distilling liquid. For this demonstration, you will need 3 such flasks. It makes sense to have weighed the flasks before you use them. We shall need to monitor the temperature of the distilling vapor. You could do this by using a quick fit thermometer, such as this, which fits directly into the still head. However, these are rather expensive, and so we shall be using instead a thermometer pocket into which is placed a conventional thermometer. The apparatus is now complete. What we need to do next is to put the liquid for distillation into the flask. So remove the thermometer and the thermometer pocket. Put a funnel into the still head and gently pour in the liquid that is to be distilled. Again, let me remind you that the size of the distillation flask must be chosen so that it is only approximately half filled by the liquid for distillation. If you have more than that in the flask, the liquid may bump and impure material may be bumped over into the receiving vessel. To avoid bumping during distillation, add 4 or 5 anti-bumping granules. These are small pieces of stone containing channels in which air is trapped. As the stones are heated, the air escapes, forming nuclei on which bubbles of vapor form. You only need to add 4 or 5 of these stones into the distillation flask. Now put the thermometer pocket back in the still head. To ensure good thermal contact between the mercury of the thermometer bulb and the glass of the pocket, put a small amount of oil in. Only use enough oil to just cover the bulb of the thermometer. Too much oil makes the response of the thermometer sluggish. For the source of heat, I shall be using a conventional Bunsen burner with tripod and gauze. Other forms of heating can be used. For example, a microburner will give you a very accurate control over the amount of heating. Alternatively, you can use an oil bath, such as this, or a sand bath, or even an air bath, simply an empty beaker. All of these being heated either electrically on a hot plate or on a tripod and gauze with a Bunsen burner. The gauze serves to spread the heat out over the surface of the flask and ensures more uniform heating. We're now ready to begin the distillation process. For liquids whose boiling point is below about 130 degrees centigrade, such as we have here, it's necessary to provide water cooling in the Liebig condenser. Set the condenser up so that the water enters at the low point and leaves at the top. That avoids trapping of air bubbles inside the condenser. Higher boiling liquids only need an air condenser. Now light the Bunsen burner. And adjust the flame from yellow to blue. As you can see, the temperature starts to rise rapidly as the distilling vapor reaches the thermometer pocket. Adjust the level of heating so that boiling occurs gently. Too vigorous boiling can cause choking around the neck of the thermometer pocket and will cause impure material to distill over. After the first few milliliters of distillate have collected, change flasks. Discard the material in the first flask. Adjust the heating so that the distillate collects at a rate of about 1 drop a second. During collection of the main fraction, the temperature of the distilling vapor should remain constant. As the distillation nears completion, you'll notice that the temperature of the distilling vapor starts to fall. At this point, change the receiving flask again, putting the third flask on. Don't forget to stopper the flask containing the major fraction. Don't let the residue in the flask evaporate to dryness. This can leave behind intractable materials which are difficult to clean out of the flask often, but more importantly, some compounds contain small amounts of impurities which, when concentrated and dried, can actually be dangerously explosive. And I'm thinking here in particular of ethers, which often contain peroxides as impurities.